Hello students, today we're going to look at the last of the four transformations, and that is dilations. We have done translations, rotations, and reflections, and so the last one we're going to do is dilations. Now dilation is a reduction. Some people call that a shrink, or enlargement of a figure by a common scale factor, and the scale factor is represented by the letter K. I don't know why it's K, but that's what it is. It's K. Okay? A dilation is the only transformation that does not preserve congruence. This means that after the dilation, the new image will be a different size, but will be the same shape. Figures that have the same shape, but are a different size, are called similar figures. Okay? Similar figures, same shape, different size. Similar figures are proportional. That means that the side lengths of all of those similar figures are proportional. Now all the angles are going to be the same, but the side lengths will be in proportion to each other. There's a hint. When we deal with dilations and scale factor, you always multiply by the scale factor. Okay? Every time you have a scale factor, you're always going to multiply by it. Sometimes it'll be a fraction, sometimes it'll be a whole number, but you're always going to multiply by the scale factor no matter what. So the algebraic representation for a scale factor is x comma y, arrow kx, ky, because I'm multiplying that k by both the x and the y, where k is the scale factor you're given. For example, if k equals 3, which means the scale factor would be 3, the algebraic representation would be x comma y, arrow 3x, 3y. Because since it's proportional, we're going to multiply that 3 by everything. You cannot have different numbers here in order for it to be a dilation. The number has to be the same. Okay? Now something I forgot to put on here I'm seeing right now is we're going to write it on we'll write it up here in this little section. If k is greater than 1, it's an enlargement. Okay? That means k is bigger than 1, sort of like 3. That means everything's going to get bigger. I'm multiplying by a number that's bigger than 1, so that means it's going to get larger. If k is between 0 and 1, it is a reduction. Now what kind of numbers do we have between 0 and 1? I think I heard you say it. Fractions or decimals. If k is a fraction between 0 and 1, then that is going to be a reduction, or it's going to be a shrink, so we're going to be making it smaller. Now you will never have a negative k. You cannot have a negative scale factor. Scale factor will always be positive. If it's a fraction or a decimal less than 1, then it's going to be a shrink or a reduction. If it's a number larger than 1, you're going to have an enlargement. Okay? Now, what if k is 1? Right, it's going to stay the same size. Okay? If k is 1, it's to stay the same size. It's not a dilation. So let's look down here. Determine, let me get to where you can actually see it. Okay? So this says, determine the coordinates of the vertices of each figure after a dilation with a given scale factor k. Then graph the original image and the dilation. Okay, so we got a scale factor. I've got 3 points, F, G, and H, and it tells me that K equals 1/2. Well, if K equals 1/2, then it must be getting smaller than the original. So what I want to do is, first of all, graph the original points. So we're going to go -4, -6. That's going to be right there, and we're going to call that F. And -4, -4 is right here, and we're going to call that G. And that is the wrong spot because I didn't look at it correctly. It should be -4, +4, and that's going to be G. And then 4, -6. So 1, 2, 3, 4, -6, and that's going to be H. Okay, so there's my original F, G, H. I can connect them. I should probably be using a ruler right now, but I'm not. And I'm close. Okay? So now I need to graph the reduction. And I'm going to do that in a different color. So the algebraic representation is going to be x comma y. Arrow, remember I multiply that k times the x and y. So that's going to be 1/2 x comma 1/2 y. So I multiply the x and the y by 1/2 to get my new point. So if f is -4, 6, then f prime would be -4 times 1/2 would be -2, and -6 times 1/2 would be -3, so that's f prime. G prime, I'm going to multiply -4 times 1/2, which would still be -2. 4 times 1/2 is +2. And then H prime, 4 times 1/2 would be 2, and -6 times 1/2 would be -3. And there are my 3 points, so I'm going to graph them. F prime is -2, -3, -2, -1, 2. So F prime. G prime is -2, +2. That's G prime. And then H prime is 2, -3, 2, -3. H prime. And when I connect, whoops, that's a really bad connection. That's why you should be using a ruler. Okay, there is my dilation. Original figure is in green, dilated figure is in purple, and you can see that it is a shrink. Okay, and we can tell it's by 1/2 because that's what the algebraic representation says. So now I'm going to leave one for you to do. So number 2, here are the ordered pairs for R, S, and T. And this one's a scale factor of 3. So you need to write the algebraic representation and tell me what R prime, S prime, and T prime are. And then graph both of them, and we will discuss it during our math workshop.